Okay, we're still subtracting mixed numbers with regrouping, and now we're going to work on the problem set. Find the difference and show all of your work. So I'm going to do most of this without a model because that's the method that I prefer and that you're more than likely going to use the most often. So here I have 2 minus 1 and 3/8. Let's rewrite that vertically just so we get in the habit of it. I'm going to borrow from the 2. So if I borrow from the 2, that 2 then becomes a 1. And we're going to regroup. Let's keep the same denominator, 8/8. So now my problem becomes 1 and 8/8 minus 1 and 3/8. 1 and 8/8 minus 1 and 3/8. Take the fraction pieces away first. 8/8 minus 3/8 gives me 5/8. 1 minus 1 gives me 0. So 5/8 is my correct answer. Here we have 4. 4 minus 2 and 2/7. We're going to regroup that 4. So I'm going to go for that 4. And I'm going to make that 4 into a 3. And I want to keep my fraction piece with the denominator 7. So I'm going to make that 3 and 7/7. Move that over. 3 and 7/7 minus 2 and 2/7. 7/7 minus 2/7 gives me 5/7. 3 minus 2 gives me 1. There's my answer there. Let's go ahead and look at this next problem. Zoom in a little bit so it's easier to see. I'm going to rewrite it vertically. 1 and 1/4 minus 1/3. 1 and 1/4 minus 1/3. Before I can do that, I'm going to need a common denominator. So what denominator do we want here? Well, I could just multiply 4 times 3 and get 12. 4 times 3 is 12. 1 times 3 is 3. 3 times 4 is 12. 1 times 4 is 4. Let's rewrite this as 1 and 3/12 minus 4/12. Now, can I do 3/12 minus 4/12? No, I cannot. So I'm going to have to regroup from that whole. So this no longer is a whole, and I'm going to give 12/12 over here. Well, 12/12 plus that 3/12 gives me 15/12. So let's do 15/12 minus 4/12 so that we can get our answer. 15/12 minus 4/12 gives me 11/12. 11/12. Let's continue on looking at number 4. Here again, we have 1 and 3/8 minus 1/2. I want a common denominator. Can't ever add or subtract without a common denominator. And I'm going to get that by making equivalent fractions and multiplying by 1. Well, here I'm going to keep that denominator of 8. So let's keep that denominator of 8. And we are going to multiply by 1 over 1 to get 3/8. Let's use that denominator of 8. 2 times 4 is 8. 1 times 4 is 4. So my new problem is 1 and 3/8 minus 4/8. Well, 3/8 minus 4/8 we cannot do, so we're going to have to regroup or borrow. I'm left with 0 wholes. I'm going to go ahead and give 8/8 over here. Well, 8/8 plus that 3/8 gives me 11/8, and I'm still subtracting that 4/8. 11/8 minus 4/8 gives me 7/8. 7/8. Let's write this problem down. 4 and 2/5 minus 3 and 3/4. Again, we want a common denominator. don't change the value of that fraction. So we've multiplied by a 1. What denominator do I want? Well, let's see. 5 times 4 is 20. So we can do a denominator of 20. 5 times 4 is 20. 2 times 4, don't change the value. Keep this worth 1. 2 times 4 is 8. 4 times 5 is 20. 3 times 5 is 15. So my problem became 4 and 8 twentieths minus 3 and 15 twentieths. Can we subtract 8 twentieths with 15 twentieths? No. So we're going to have to regroup. That 4 now becomes a 3. We're going to give 20 twentieths over here. Well, 20 twentieths with that 8 twentieths that was already there gives me 28 twentieths. And I'm going to subtract from that 3 and 15 twentieths. Well, 28 minus 15, I know I keep my denominator of 20, we get 13 twentieths. 3 minus 3 is 0, so my final answer is 13 twentieths. 13 twentieths. Let's look at number 6. Number 6. So we have 7 and 1/5 minus 4 and 1/3. We need a common denominator before we can subtract them. And we can use a common denominator of 15. 5 times 3 is 15. 3 times 5 is 15. 1 times 5 is 5. 5 times 3 is 15. 1 times 3 is 3. So my new problem is 7 and 3/15 minus 4 and 5/15. Can I take 5/15 away from 3/15? No, I cannot. So we're going to have to regroup. That 7 becomes a 6. We're going to give 15/15 over here and combine that with the 3/15 that were already there. 15 plus 3 gives me 18. So now we have 6 and 18/15 minus 4 and 5/15. Can I do 18/15 minus 5/15? Yes, I can. And I get 13/15. 6 minus 4 gives me 2. Gives me 2. Sam had 1 1/2 meters of rope. He cut off 5/8 meters and used it for a project. How much rope does Sam have left? Well, that's a subtraction problem right there. We have 1 1/2 minus the 5/8. Let's rewrite that vertically. 1 1/2 minus 5/8. We're going to multiply by that giant 1 so we don't change the value of our fraction. And I'm going to have a denominator of 8 because I know 8 can multiply to be 8 and 2 can multiply to be 8. 8 times 1, 5 times 1, we get the same thing. 2 times 4 is 8. 1 times 4 gives me 4. So my problem became 1 and 4/8 minus 5/8. We're going to have to borrow from the ones place. That's going to become a 0. We're going to give 8/8 over here, and 4/8 plus that 8/8 gives me 12/8. 12/8 minus 5/8 gives me 7/8. 7/8. Toby wrote the following. 7 1/4 minus 3 3/4 equals 4 2/4 equals 4 1/2. Is Toby's calculation correct? Draw a model to support your answer. Well, is it correct? Let's see. 1/4 minus 3/4, I couldn't do that. I'd have to borrow. This would become a 6. This would become 5/4. Well, 5/4 minus 3/4 is in fact 2/4. But 6 minus 3 is not 4. So, Toby's calculation is incorrect. Toby's calculation is incorrect. So let's draw our model. 1, 2, 3, 4, 5, 6, 7, and 1/4. I'm shading in the amount that I actually have. Okay. Then I'm going to subtract my 3 3/4. Well, I can't take 3/4 away from that. So let's break this up into 2/4. I take away 1, 2, 3 of the fourths. I'm going to take away 3 halves, or 3 wholes, 1, 2, 3, and I'm left with 1, 2, 3, and 2/4, also known as 3 1/2. So I see that with my drawing, with my model, that Toby is incorrect.